8.3, Trigonometry. Yay, trig is fun. Before we get started here, we need to go through some things that need to happen, some background information. When you're doing trig on your calculator, you need to make sure that you are set for your calculator to work in degrees because we are measuring around a circle. Right now your calculator is set in radians, and that counts around a circle in terms of pi. When we do trig, we are counting in degrees. So on your calculator, you click the mode button, you page down and then page over to where it says degree and then enter. And you should always check your calculator. And to do that, you type in sine 90, enter, and that will equal 1. If sine 90 does not equal 1, your calculator is not in the right mode. Now trig, all you have to remember for trig is SOHCAHTOA. SOHCAHTOA, SOHCAHTOA. And we'll get to that more later. If you go into your pre-calc class and you go, I know SOHCAHTOA, your teacher will be very happy with you. And another terminology here, we have a new symbol. The measure of angle A is now going to be represented by theta. So theta is just in degrees. It's just the measure of angle A. So for example, we would say theta equals 37 degrees. So theta is just another way of representing the measure of an angle. Okay? Okay, we can get started then. Our objective is to use the sine, cosine, and tangent ratios to determine side lengths and angle measures in right triangles. Of course it's right triangles because that's what chapter 8 is about. So let's get into this here. Our trig ratios, to do these, page down a little bit here, step 1, you always mark your angle because that determines where everything is. Your formulas that you're going to use are determined by which angle you're looking at. So we mark our angle. And in this example here, we are talking about angle A. So I mark angle A. And then in step 2, you label your sides. Well, what sides are going to be important to us? The opposite side. So which side is opposite angle A here? It's over here. That doesn't look much like opposite, does it? Okay, and in a right triangle, who's always important? The hypotenuse. We know where the hypotenuse is. And then lastly, we need the side adjacent to angle A. Now, the hypotenuse is adjacent to angle A, but it's already the hypotenuse and is already special. So we label opposite hypotenuse, and then side B here is adjacent to angle A. Now let's look at our trig ratios. The sine of angle A is the length of the leg opposite over the length of the hypotenuse. So sine theta equals opposite over hypotenuse. So the cosine of angle A is the length of the leg adjacent to the angle over the length of the hypotenuse. So cosine theta equals adjacent over hypotenuse. Ka. And the tangent of angle A is the length of the leg opposite over the length of the leg adjacent. Therefore, tangent of theta equals opposite over adjacent. TOA. So, ka, TOA. Pretty cool, huh? Probably one of the easiest formulas to remember. So, ka, TOA. Now, sine theta, you're probably going, oh, no. However, we're going to deal with that. That is just a number. These represent numbers. You've become very comfortable with x being a number, y being a number. You've become comfortable with the symbol m angle A is a number, right? The measure of angle A is just a number. Sine theta, cosine theta, tangent theta, these are just numbers, and they're numbers that we can find in our trig table. And we will get to that shortly. It's in the back of your notes, so when I refer to it, that's where you go. Let's look at how this works. Let's start using these some, and you'll go, oh, those are really cool. The Leaning Tower of Pisa, it tilts, and about 15 years ago, it tilted way too much and became unsafe. They had to close it. So the engineers went in and kind of pushed it back up a little bit, and they were able to reduce its tilt to about 5 degrees. From 5.5 degrees, you wouldn't think that half a degree was a lot, but it was. And so it says, someone drops an object from the tower. Don't try this at home. Drops an object from the tower at a height of 150 feet. How far from the base of the tower will the object land? So, bad tourist is up here and drops the object. We know this is 150 feet, and what we want to know is this distance right here. So you can see we have a triangle, and I'm going to redraw my triangle here, and make it a little bit easier to deal with. So we know that this is 150 feet. We know this is x feet, and we know this angle here is 5 degrees. So we want to figure out how to solve this. What's the first thing we do? Number one, we mark our angle. I'm using this angle right here. That means this is my opposite side, this is my hypotenuse, and this is the adjacent side. So now we look, which sides do we have? We have opposite and adjacent. All right, we've got an x and a 150. The hypotenuse has no numbers on it. That means we are going to use the tangent, right? Is opposite over adjacent. So we write our formula. Tangent of theta equals opposite over adjacent. And I fill in the tangent of 5 degrees equals, what's the opposite? It's x over the adjacent is 150. Now, tangent of 5 is just a number, and your calculator knows how to deal with it. So how would we solve? Let's go over to the written problem here. How would we solve for x? This is just an algebra problem. We would multiply, we'd put over 1, right? Multiply by 150 on both sides. We don't need the over 1. We could also cross multiply if you wanted to. Those cancel, and we get x equals 150 times the tangent of 5 degrees. Tangent of 5 degrees is just a number. So in our calculator, you type 150, and then you hit the tangent button, and then you hit the 5 button, and then you hit the enter button, and your calculator spits out a number. So the object will land about 13 feet from the base of the tower. That's pretty good. Now, go take a look at your trig table. All right, here's our trig table. It's in the back of your notes. We are looking at the tangent of 5 degrees. Notice you have your angle measure and your sine, cosine, and tangent of that angle. So we are looking here at 5 degrees, and we go over to tangent. We want the tangent of 5 degrees. Look at that. It is just a number. It is 0.0875. And so you don't even need a calculator to do these problems because you have a tangent table, right? You could just say, I need tangent of 5 degrees, and you put 0.0875 in there, multiply that by 150, and you're going to get about 13 feet. All right, so let's go back to our notes. So here, if instead of tangent 5, we put 0.0875 and multiplied by that by 150, we would get the same number. All right, so we'll leave this pretty close to here. Push these up a little bit. You have 3 problems here. You know how to solve algebra problems. You can turn them into fraction equals fraction and cross multiply if you need to. There's my hint. Pause the video and do the next 3 problems. These problems were not too bad. A little bit of writing involved, but that's okay. A little bit of hard work won't kill you. These are going to be good examples of, if you know the angle, how to find a side. Keep these for reference. The first one, well, on all of them, I marked my angle. I labeled opposite, hypotenuse, and adjacent. On the first one here, I could see that I had opposite and hypotenuse. That means I'm using so. So sine of theta equals opposite over hypotenuse. I'd put my numbers in, sine of 54. And this is just algebra. Multiplied 17 on both sides, I get W equals 17 sine 54. Now, the sine of 54 degrees is just a number. You could either put this into your calculator or you can look it up on your trig table. On the trig table, it's 0.8090. So 17 times sine of 54 is 13.75 in a lot of decimal places there. So we were told to round to the nearest tenth. The side length is 13.8. Now, does that seem reasonable? Well, we know our hypotenuse is 17. So yeah, that fits right in there. We know it has to be less than the hypotenuse, and that's a good number. The next one, we had opposite and adjacent sides. So opposite and adjacent means TOA. So tangent of theta. Now this time, go back. This time our variable is on the bottom. How on earth are we going to deal with that? It's just algebra. I put my tangent over 1 and then cross multiply. So I end up with W times tangent 28, just a number, and equals 1. And then I divide both sides by tangent 28 because tangent of 28 degrees, just a number. So W, these cancel right here, and W is 1 divided by tangent of 28 degrees. Tan 28 is 0.5317 from your trig table, or your calculator knows how to do this. It knows tangent 28 is a number. Put that in my calculator, we get 1.88. So W equals 1.9. Let's check that. Does that seem reasonable? Yes. Our other side is 1.0, so 1.9 is not outrageous number. The last one here, we have adjacent and hypotenuse. So that means we are using CA. So cosine theta is adjacent over hypotenuse. So put all my numbers in. This one was just like the first one. Multiply by 4.5 on both sides. W is 4.5 times cosine of 33, which from the trig table is 0.8387, or your calculator knows how to do it. You just type in 4.5 cosine 33, hit the enter button, it'll give you 3.77401, which is 3.8. Is that reasonable? Yes, it is. It's in that range and it's smaller than the hypotenuse, so all is good. Okay. Oh, it looks like we have another problem here. We'll do this one together. That doesn't hurt. It says a section of Filbert Street in San Francisco rises at an angle of about 17 degrees. If you walk 150 feet up this section, what is your vertical rise? All right, that's a clue right there. Vertical rise. And we walk up the street, 150 feet up the street. So what do you suppose this looks like? Our street rises up. We can make this. And we want to know, this would be our vertical rise. And we walk 150 feet up the street, right? This is just a hill. We're walking up a hill. And we know that the angle is 17 degrees. So we can make a right triangle out of this. Means we can use trig. Opposite, hypotenuse, adjacent. Which ones do we have? We have opposite and hypotenuse. So we're going to use So sine theta equals opposite over hypotenuse. Sine 17 is x over 150. Multiply both sides by 150. So that cancels. X equals 150 sine 17 degrees. And we can put it in our calculator or on your trig table. That is 0.2924. So x is 43.855755571, or nearest foot. We're about 44 feet higher than when we started. That's a pretty steep hill. San Francisco has some pretty steep hills. Okay. So forward trig, not too bad. Label your triangles, write your formula, everything's easy. Use your calculator, trig table, everything's easy. What happens when we know the side but want to find the angle? Well, you look at these examples. Now, the first one here, we want to find the measure of angle x. So I mark my angle, label my sides. Which two do I have? We have opposite and hypotenuse. So that's right. We're going to use sine. So I write sine theta equals opposite over hypotenuse. Sine theta equals opposite is 6 hypotenuse is 10. Now we can use our trig table. Okay, we're here at our trig table. We are looking for sine, right? We're using sine and we want 0.6. So we go down the sine column until we get to 0.6. Here's our sine column. And that is pretty close to 0.6. And what is the angle measure? 37 degrees. So let's go back to our notes. We're going to write this differently. So sine theta equals 0.6. And we looked at our trig table. So from our trig table, we got, that's about 37 degrees. All right, so that's an easy way to do this. Let's look at how to do it mathematically with your calculator, because calculators are awesome. So we get sine theta is 6/10. Now, what if we wanted to solve for theta? What would we do? We would divide by sine, right? But sine is kind of like a fraction. You can't divide by a fraction. What do? You multiply by the reciprocal. Well, sine is kind of the same way. We need to write this where we have a little more space. We need to write this a little more space. Instead of dividing by sine, I am going to multiply both sides by inverse sine. And that -1 means inverse. So what's going to happen here is these two are going to cancel. And I'm going to be left with theta equals the inverse sine of 6/10. And this is what goes in your calculator. You do inverse sine of 6 divided by 10. I highly recommend using the parentheses, enter, and guess what? Your calculator spits out about 37 degrees. Your calculator will be more specific than your trig table. There's ways of dealing with that, but we won't. That's for your Algebra 2 and pre-calc teacher. All right, so let's look at the next one here. We're still looking for angle X, opposite, hypotenuse, adjacent. So what do we have? We have adjacent and hypotenuse, so we are using cosine. So cosine theta is adjacent over hypotenuse. So cosine theta equals, what's adjacent? 15/20. So we can do cosine of theta equals, what's 15 divided by 20? 0.75. You can go look at your trig table. And cosine of 0.75 is about 41.4, about 41 degrees, 41, 42 degrees on your trig table. Or we can do cosine theta equals 15/20, and you can leave it as a decimal if you want. Multiply both sides by inverse cosine. Those cancel. So theta equals inverse cosine of 15/20. And what that comes out on your calculator, 41.4. So 41, 42 degrees. This one would round down, just barely. Okay. Last thing to do here is for you to do the next two problems. Pause the video, give it a try. Last two problems, not too bad. As long as you are labeling and writing your formulas, life will be okay. So I labeled angle Y, opposite, hypotenuse, adjacent. I have opposite and adjacent. That means we're using tangent. So we do tangent theta of 100 over 41. And if I want to use my trig table, that fraction is 2.43902. The trig table closest is 2.4751, which is 68 degrees. If I'm using my calculator, the theta equals inverse tan of 100 over 41, which is 67.7, which is about 68 degrees. Last problem here was not too bad. Suppose you know the lengths of all three sides of a right triangle. Does it matter which trig ratio you use? Not in the least. You can find any angle, any side, because this is all based on the Pythagorean theorem. So, and I'll show you a little video on how all this works. You don't need to know those details. That's for your upper math classes. So I just drew a right triangle here, a 3, 4, 5. We know 3, 4, 5 is always a right triangle. Picked an angle, doesn't matter. Opposite, adjacent, hypotenuse. Sine theta, if I use my calculator, I get about 53 degrees. If I use my trig table, that's 0.8 under sine is 53 degrees. Cosine, adjacent over hypotenuse, about 53 degrees. Tangent, opposite over adjacent, about 53 degrees. Let's go take a look at our trig table and look at sine 0.8, cosine 0.6, and tangent 1.333. See you at the trig table. All right, so we want sine 0.8, cosine 0.6, and tangent 1.333. Well, where are we going to get that? This is one of these two is about as close to 0.8 as you can get. This one's probably a little closer. It's hard to tell. One of those two. 0.6 for cosine. This top one's the best one. That one. That's closer to, come on, it's closer to 0.6 there. And 1.333, that's definitely here on the tangent. So you can see 53 degrees. This is closer to 0.81, so we would not use that one. This is the closest to 0.8. So you can see they're all right here. Because you're using different sides, you get a different ratio. Doesn't matter which one you use. All right, trigonometry, ton of fun. SOHCAHTOA. Remember to check your calculators. Sine 90 equals 1. You will be sad if you get all the wrong answers because you didn't check your calculator and change to degrees. I know this is an entirely new concept. I believe you can do it. Just make sure you are label, and write your formula. And then let your calculator do the work for you, or your trig table. This is what we did before there were calculators. All right, so have fun with the homework.